One thing that's a little bit different about this test compared to the last test is on the last test there was one final force problem that involved kinematics, but that's not the case here. So there's just going to be a couple of force problems. One of those force problems is going to require the use of the drag formula, and one of them is not. So number 4, you're given the rocket, you're given its velocity, and it tells you the direction of the acceleration and the magnitude of the acceleration, and it gives you a drag force, and it requires you to draw a diagram showing all the forces acting on the rocket, and you've got to label things and do things in a specific way. So for both of these problems, it's really good to understand all the stages of a rocket's flight. That'll help you picture what's happening in here. So if you know what's happening, what the forces are that are at play, that'll help. So it's falling from the sky, and it's accelerating upward. Maybe you don't know anything, so you could just draw it falling from the sky. So you draw your rocket falling down, and you know that it's experiencing a drag force of 2 newtons. So you could draw this. So in the beginning I drew drag of 2 newtons. Now it's important to know that if it's falling, the drag is going to be up. So I know that I've got a positive 2 Newton force there. And what else do I know here? Oh, this is, I guess that's it. So I know there's that force, and I know this is the acceleration, and I know that's the velocity. That ends up being a little bit of a red herring. You don't really need that number. That doesn't do anything. You just need to know there's a negative velocity so that you know that there's positive 2 newtons of drag. So what can you do in a force problem? You can do this. You can write 2 equations for net force. Net force equals ma, and the net force equals the sum of the forces acting on it. When a rocket's falling from the sky, there are only 2 forces. There's the drag and there's the weight. That's it. So the net force is drag minus weight, and the net force is ma. So fleshing this out a little further, ma is m times 1.5 because that's the acceleration, and net force is the drag minus mg because mg is weight, and then I can set this equal to this, and when I do I get this ma, that's the net force, and then this is drag minus weight, and I can solve for m. So when you solve for m, you get 0.177 kilograms, and that allows me to calculate the weight. The weight is mass times g, 1.73. And once I have those 2 forces, then I can put them back in here and get the net force. The net force is going to be 2 minus 1.73, and that is 0.265. So now I have all the forces. And I can check all this if I want to. I could do 0.265 divided by 1.5, and that should give me the mass. And then I could use that mass again to calculate this weight and make sure it's right. There are a lot of ways to check your work there. This is kind of a tricky one, though, because you end up with like not being able to fully calculate either of these until you set them equal and solve for m. Just trust that if you use F equals ma and F equals the sum of the forces and you set them equal, you'll be able to solve the problem. So this problem, one of the 2 will require you to use the drag equation in some way. You'll be provided the drag equation. And both of the force problems, you're going to have to draw a diagram showing all the forces. So here, we're just given some data. You're given the cross-sectional area, density. So all this stuff, or at least most of it, allows you to calculate drag. There's 0.5. This is the drag coefficient, 0.3, cross-sectional area, density of the air, and then the velocity squared. That comes out to 5.72. That's the force of drag. So remember that. The rocket velocity is upward. The rocket's going up, then drag is down. So when I draw this picture, I need to have drag going down. Another force that's always acting on your rocket is weight. And the weight we can just calculate if we have mass, and we do. Got the mass. The mass times 9.8, 0.25 times 9.8 gives me 2.45, and it's downward. And what else do I have? I'm given the acceleration. So let me jump to the important equations. All force problems, you set F equal to ma and then F equal to the sum of the forces, and then you set those two things equal. So F equals ma, I can just do, I've got everything. There's the mass, there's the acceleration, so the net force is 5 newtons. And that equals the sum of all the forces. So 5 newtons equals negative 5.72, that's the drag, minus 2.45, that's the weight. And if I just stopped there, I would get negative 5 equals like negative 8, which makes no sense. So what that's telling me is there has to be another force. And if the rocket's going up, there's only one other possible force that could be acting on it, and that's thrust. So this must be where when the rocket is speeding up. There's no other point in the rocket's flight where it's going up and there's some other force besides drag and weight. So this missing force here has to be thrust. So the net force using F equals ma is 5 newtons, and that equals the sum of these three forces. The thrust minus the drag minus the weight. So my little question mark represents thrust. Solve for question mark and you get 13.2. And that's it.